So let's talk some triangular decomposition. An alternative method for finding a square root matrix of a square matrix, in addition to spectral decomposition, which we talked about in the previous video, is triangular decomposition. Although this method gives a different kind of root matrix than spectral decomposition, it will also yield the original target matrix when pre-multiplied by its transpose. Now, as the name implies, triangular decomposition will give us a triangular matrix. Now, remember we have matrix A, which is a simple 3x3 square symmetric matrix. And it has the values. Let's move that over here. Has the values 4, 6, 2, 6, 16, 3, and 2, 3, 9. Using the Cholesky algorithm, we obtain the triangular square root matrix T of this A matrix. And we did that in video 3.23. And we found T to be this: 2, 3, 1, 0, square root of 7, 0, 0, 0, square root of 8. When we pre-multiply this T matrix by its transpose in order to square it, we see that the squaring process yields matrix A. And I'll just, even though we did that in the video when we talked about the Cholesky method of obtaining a triangular square root matrix, I'm going to do it again here. We have transpose of T times T. So what we'll have is 2, 0, 0, 3 square root of 7, 0, 1, 0, square root of 8, times 2, 3, 1, 0, square root of 7, 0, 0, 0, square root of 8. And in fact, when we multiply those together, we do get 4, 6, 2, 6, 16, 3, and 2, 3, 9, which is matrix A up here. Therefore, T is a true square root matrix of A. And this is the process of triangular decomposition. Now, when we talked about spectral decomposition, we did find a different value for the square root of matrix A. The square root of the same A matrix was obtained by the eigenvectors, eigenvalues method. And we found that to be this. Actually go over to Excel here. We found it to be this in the previous video. Even though this square root matrix is not triangular and seems to have little in common with matrix T, other than that they're both 3x3 matrices, we also see that it is also a root matrix of A. When we multiplied it by itself, we did get A. And notice that this matrix A to the 1/2 power, the square root of A, is a symmetric square root matrix. And because of this, we know that the transpose of this is going to equal itself, and we can easily demonstrate that. And we can do so just by taking the transpose of that square root matrix, and it should look like itself, which it does. So in this video and the previous video, both on spectral and triangular decomposition, we have found two different square root matrices of A, but both are true square root matrices of our matrix A here.